This is numbers 5 and 6 on the unit study guide. We're told that Katie has a picture that is 30 inches long and 21 inches wide. Lucy wants to make a scale drawing of this picture so that it has a width of 3.5 centimeters. And it asks what should the scale length be of this drawing. So we're going to start by drawing a picture. We'll say that that's the original. And it says that it's 30 inches long and it's 21 inches wide. Push this over just a little bit. Alright, and then we're supposed to look at that and make it into a scale drawing. With our scale drawing, we are told that it's going to be 3.5 centimeters width, and what we're trying to find out is this length, which we don't know. Well, we can set up a proportion here. You can set this up multiple ways. If we want, we can set it up with the big one, so it's 21 inches is the width, 30 inches is the length. So look, this is the width, this is the length, this is all on the big one. So then we can compare that to the small one, where again we're looking for the width on top and the length on the bottom. Well, the width on top is going to be 3.5 centimeters, the length on the bottom is going to be x. So then we're going to cross multiply. We get 21 times x is going to equal, and then we're going to do 30 times 3.5, which we get is 105, and then we're going to divide both sides by 21, so that when we do that, x is going to equal 5. Now, it's 5 what? It's going to be 5, look at what the small drawing unit is. We already had the inches here, we're comparing centimeters to, in this case it's going to be centimeters, so 5 centimeters will be my answer choice. On the next one, we have been given a proof, so we're going to go ahead and set this up. Statements, reasons. Alright, so number 1, we're told that MQ is going to equal 1/3 MN, and we're also told that MR is going to equal 1/3 MP, and that's given. Now, if you'll remember in class, whenever we had this and we were trying to prove that two triangles were similar, these ratios were important because we wanted to be able to compare the side lengths to their actual ratio. The problem is that here we have this letter right here, the segment MN, and we really don't want that. We really want it to be over here written as a ratio. So if this is 1/3 times MN, I want you to look at this. So we have MQ is equal to 1/3 times MN. If I actually divide both sides by MN, what happens? Well, here on this side, the MNs would cancel, and that would leave me with MQ over MN is going to equal a 1:3 ratio. So, what I'm going to do for number 2 is I'm going to go ahead and write that MQ over MN is going to be a 1:3 ratio. I'm going to do the same with this one here. If I divide both sides by MP, the MPs would cancel over here, and on this side I would have MR to MP would be 1/3. So notice they both have the same side ratio. So this right here was the division property of equality. And now I have one more thing. I've got two sides that are proportional, and look at the sides that I have proportional. It's MQ to MN, and it's MR to MP. If you'll remember that this right here we can also say is congruent to itself, that angle M. Why? Well, because this particular angle here is going to be the reflexive property. So number 3, I'm going to say that angle NMP is going to be congruent to angle QMR, and that is the reflexive property. Now, if you'll notice, we have a side, an angle, and a side, so I can say number 4, that triangle MQR is similar to triangle MNP, and the reason would be SAS similarity.